This video is on section 10.4, area and circumference. We've already seen that area is the number of square units needed to cover a figure. Now we looked at this from the standpoint of actually counting the square units a couple sections ago. Now we're going to introduce some formulas that you probably already know. So the area of a rectangle is just length times width. The length of the rectangle, the width of the rectangle, so let's say this is 10 centimeters and the width is 4 centimeters. Then the area is 10 times 4, which is 40 square centimeters. That means if I actually had some little square centimeters and placed them in here, it would take 40 little carpet tiles to cover that area. A square is given by this, area equals s squared. You could still think length times width. It just so happens that these two sides are the same, and that's why the area of the square is s squared. So if this is 7, then our area is 7 squared, which is 49, let's say this was centimeters, 49 square centimeters. Something a little more complicated is to find the area of this figure right here, which is made up of rectangles. And what we need to do is cut this into smaller rectangles that we can find the area of. So one way to cut this is to cut just like this, straight across here. And this is a rectangle that is a 3 by something rectangle. It's not just 13. This is 13. Can you tell what this is? Remember, we looked at this before when we did some perimeter problems, and that is you need to look opposite. If this down here is 3, then this is 3, which makes this whole length 16. So this is a 3 by 16 rectangle, which makes 48 square feet. Then I can look at this rectangle, and it is clearly a 6 by 3 rectangle, which is 18 square feet, and we just have to add those up, and we get 66 square feet. You could chop it another way. You could, instead of chopping here, you could have chopped there. You would have different individual areas, but the sum would be the same. The area of a parallelogram is this formula. Area equals b for base times height. The base is this right here, and the height is referring to the perpendicular distance. So find the area of this. This is just a 4 by 8, which is 32 square centimeters. Now you look over here and you see 4 by 8. The 8 is only this part right here. The 8 is only that part right there. So that we do need this 5 to help us find this value down here. Remember, this is a right triangle. In a right triangle, we know that we can use Pythagorean theorem to find a missing side. So this is a squared plus b squared equals c squared. Remember also that the 5 has to stand alone because it is the hypotenuse. So this is a squared plus 4 squared. So that's a squared plus 16 equals 25. Subtract 16 from both sides, gives us a squared equals 9. To undo the squared, take the square root, and a is 3. So we've now found out that this portion right here is 3. How does that help? Well, that will help me find the whole base. The whole base is 3 plus 8, which is 11. The height is right there. 11 times 4 is 44 square centimeters. The area of a triangle is 1/2 times the base times the height, because look back at this parallelogram right here. You can chop the parallelogram in half with that diagonal, and you are creating 2 triangles. So that's why the area of a triangle is 1/2 times the base times the height. Here's the base, and here's the height right here. They are joined by the box, which is the right angle. So here we've got some information we don't need. We don't need these 2 sides. The area of the triangle is 1/2 times the base times the height. And how you do this arithmetic is your choice. Back in the old days before calculators, I would suggest that you reduce. 2 goes into 16 8 times. 8 times 10 is 80, and that works just fine. You could do 16 times 10 is 160, and then divide that by 2, which is the taking half. You can type this in your calculator directly. You can use a half as a half or use 0.5. So use whatever works for you in your calculator. Now unit-wise, this is square meters. Keep in mind we're talking area. Area units are always square units. This triangle, still you have to look at base times height. It is just, this is the base, and the height had to be drawn outside of the triangle because this is an obtuse triangle. That doesn't matter. The height is indicated by where that box is. The height is referring to the perpendicular distance. So this and this we don't need. This is 1/2 times the base, which is 12, times the height, which is 9. I just reduce, and we get 6 times 9 is 54 square inches. With this triangle, you may have a problem finding the base and the height, but you need to look at it this way. When you have a right triangle, wherever your box is, that's indicating your base and your height. So in a right triangle, your base is one of the legs, your height is the other leg. But I have to figure out this other leg by using Pythagorean theorem. So this is a squared plus 48 squared equals 50 squared. So a squared stays as a squared. 48 squared is 2,304. 50 squared is 2,500. Subtract 2,304 from both sides. So a squared is 196. Undo the squared by taking the square root, and a is 14. And you might think, oh, you're finished, but you're not. All of that work was just to find out what this was. We are still doing the area formula, which is area equals 1/2 times the base of 48 times that height of 14 that we just found here. Multiply that up any way you want, and you'll get 336 square inches. A trapezoid is a quadrilateral with exactly one pair of parallel sides. In this case, it's the top and the bottom. The top and the bottom. And the formula is this. Area equals 1/2 h times a plus b. Now that may look kind of like the triangle formula, and it's because that trapezoid can be chopped into two separate triangles. So h is the height, it's where the box is, it's the perpendicular distance, and the a and the b refer to the two parallel sides. And in this case, it refers to the top and the bottom. But there are some trapezoids that look like this, where your two parallel sides are here. This would be your A and your B, so be careful of that. So using this picture, our area is 1/2 times h, which is 13, the quantity A, which is 32, plus 46. So order of operation, of course, if you have a calculator that does order of operations, you can type it in exactly the way you see it. If your calculator is more of the little cheapy rubber button calculator, then you need to follow your order of operations. Add this up as 78. You could then enter it in the calculator that way. You could reduce 2 into 78 and get 39, and then do 13 times 39. Whatever way you want to go, you should get 507 square feet. So let's find the area of this figure. It's a little more complicated than just your basic figures. This is a pentagon. We don't have any formula for finding the area of a pentagon, so we need to think about chopping this into two recognizable figures. I hope that is recognizable. The bottom is a rectangle, and the area of a rectangle is length times width. So for the rectangle, we're looking at 14 times 30, which is 420 square meters. But now we have to look at the top, which is a triangle. We do know this base. This base is also 30 because this is a rectangle. What we also need is the height. Any way to figure this out? The answer is yes, because they've shown us that this whole thing is 22. If that whole thing is 22 and this part is 14, what's left for this upper part is 8. So 8 is the height of this triangle. So the area of the triangle is 1/2 times the base, which is 30, times the height, which is 8, which gives us 120 square meters. So add those two up to get the total area, which is 540 square meters. This I'm going to show you a different way to do than what they probably want you to do. There's an old geometry formula that's worth remembering for this, and that is the area of any quadrilateral with perpendicular diagonals. Diagonals are these lines that go through the middle here. They are perpendicular because we have the box. So the easier formula to use is this right here. Area equals 1/2 times D1 times D2. And what D1 and D2 refer to are your diagonals. So I'm going to call this one D1. How long is that diagonal? Well, they've told me it's 15 feet to here, and then 6 more feet to the end. 15 plus 6 is 21. Now the red diagonal is this one here, which is 8 feet for the top part, 8 feet for the bottom part, which makes 16. And then I can multiply that out with the calculator and get 168 square feet.